All right, but 3.3, proofs with parallel lines. So we're going to use the properties that we learned last week. Before, if we had two parallel lines, so let's say these were parallel. Because they were parallel, there were relationships built. Like, what relationship would these two angles have? They're corresponding, okay? And because they were parallel, what could we then figure out about their measures? They were congruent, okay? So now it's going to be the opposite. So you're going to try to prove that lines are parallel. So you'll be given a picture like this, and it'll say, are these lines parallel? And you'll say, because these two corresponding angles are congruent, the lines are parallel. So it's just going to be the opposite of what you've already learned, okay? These are the things we're going to talk about today. You won't need your student journal. First, we're going to review what parallel lines are. They're lines what? Yeah, they're on the same plane, so you want to write that they're coplanar. That's the first line. Coplanar lines that do not intersect. Coplanar lines that do not intersect. All right, and what would signify that you have two parallel lines? What would you look at this picture and see? The arrows, okay, they look like triangles here. They're super teeny tiny. So they're either triangles or they would just be arrows on the line. And then what was the symbol for parallel lines? The two lines, the twin towers, okay? All right, that was parallel lines. The second word that's on your paper is transversal. I'll give you the short definition. It's one line that cuts through two or more lines. So one line that cuts through two or more lines. All right, what line is the transversal in this picture that we see? Yeah, the straight line going up and down. This is our transversal. Therefore, it creates a couple of different relationships that we will review. First relationship that we will review are corresponding angles. All right, so who can list a pair of corresponding angles? 1 and 5, I agree. All right, what is another set? 2 and 6. Then we'll have 3 and 7. And then we got 4 and 8. Okay, so they're on the same spot at their perspective intersections. 1's in the top left, 5's in the top left, 2's in the top right, 6 is in the top right, 3's bottom left, 7's bottom left, and then 4 and 8. Those are corresponding. What did we know about corresponding angles? Well, about their measures. Yeah, they were congruent. All right. Now we have alternate interior angles. So interior of what? What would help me figure out what's interior? That doesn't go there. What? On the inside of what? Yeah, you draw your box between your two lines. All right, so interior, we're not talking about these angles or these angles. All right, interior, and then what do they alternate across? The transversal. Okay, so if we had 3, what is 3 alternate interior with? 6. And then we got 4 and 5. Good. And then what did we know about their measures? Yeah, they were congruent as well. We got alternate exterior. It's the same thing. Oops. Same thing, except for now we're only dealing with what's outside. All right, so what would be one of my pairs? 1 and 8. 2 and 7. Good. 2 and 7. And then what did we know about their measures? They were also congruent. Good. We have one more. It was consecutive interior. So where do both of these have to be? Inside. And then what does consecutive mean? Same side of what? The transversal. Okay, so our first pair would be what numbers? 3 and 5. So these two would be a pair. And then on the other side, 4 and 6. Okay, 3 and 5, 4 and 6. All right, so because of these, we're going to talk about the converse. If you had two pairs of parallel lines, then that made corresponding angles congruent. That made alternate interior angles congruent, exterior angles congruent. Consecutive interior angles, what was their measure? Supplementary. Okay? So because you had two parallel lines, that made them congruent or supplementary. Now you're going to do the opposite. So this is where we're going to go to your notes. The first box, you're going to write corresponding angles. So the first box on the left, corresponding angles. So the theorem used to be if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Now the converse is written on the right side. If pairs of corresponding angles are congruent, then we can conclude that the lines are parallel. So we're going to use corresponding angles being congruent to prove that lines are parallel. So your blank would be congruent. There you go. All right, the next one, alternate exterior angles, will go in that box. Alternate exterior angles. The theorem again used to be if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. Now if you flip them like a converse, if two pairs of alternate exterior angles are congruent, then the lines are parallel. Okay, so we're using the opposite. All right, next one, alternate interior angles will go in your box. It used to be if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. The converse would be, if the pairs of alternate interior angles are congruent, then the lines are parallel. And then you see your last one, consecutive interior angles. If pairs of consecutive interior angles are supplementary, then the lines are parallel. All right, so these are the four properties we'll use to prove that lines are parallel. Okay? So before, if you had two parallel lines cut by a transversal, corresponding angles were congruent. Now you could say, if they asked if J and K were parallel, you could say, well, because angle 1 and angle 5, what does this symbol mean? Are congruent, then J and K are parallel. Okay? You would use that for all of your corresponding angles. Okay? Before, it would say if they're parallel, then these two would be congruent. Now, because we know they're congruent, we can conclude that the two lines are parallel. Okay? Same thing with alternate interior. Because they're congruent, 3 and 6, 4 and 5, that makes the lines parallel. Alternate exterior, like we talked about, 1 and 8 are congruent. 2 and 7 are congruent. That makes the lines parallel. Then the last, this one is the hardest for most students. Again, what does supplementary mean? They add up and equal 180. So that means if angle 3, the measure of angle 3, and the measure of angle 5 equals 180, then J and K are parallel. And the same things with 4 and 6. If they add up and equal 180, then J and K will be parallel. Okay, so we're going to use them. We're going to go to the bottom of the notes. Decide whether there is enough information to prove that P, what does this symbol mean? This one up here, is parallel to Q. If so, state the theorem. So you can just tell me what relationship you used. There are 4 options. Okay, there would be corresponding, like we talked about. What do corresponding angles have to be? Congruent. And then there was alternate interior, which had to be congruent. Then there was alternate exterior, which had to be congruent. And the last we're looking for would be consecutive interior, which would be supplementary. So those are the 4 that we're going to use to decide whether or not these are parallel. All right, so number 3, what relationship, if any, is pictured here? What relationship do these two angles have? They're corresponding, yeah. So they're corresponding. So what do corresponding angles have to be in order for the lines to be parallel? They have to be congruent. So let's look and see if they are. Okay? So what do these curve marks mean? That they're what? That they're the same measure. Okay? And same measure means congruent. So because these corresponding angles are the same measure, all right, that is enough information to decide that P is parallel to Q. So you would say, yes, there's enough information. Okay? And then you would say corresponding angles are congruent. Yes, because corresponding angles are congruent. And this would be your answer. I accidentally paused when she went to speak on the intercom. These are just the 4, if you're listening on the recording, these are just the 4 properties that would prove that lines are parallel. All right, let's look at the next one. Is there a relationship between, on number 4, between the 2 angles that they have highlighted? Let's check. Are they both on the inside, outside, or neither? Neither. They're not both on the inside, so they can't be alternate interior or consecutive interior. They're not both on the outside, so they can't be alternate exterior. Corresponding would have to be in the same spot at their intersection. This top one is in the top right, all right, and then this other one would be in the top left of its intersection. So there's no relationship, so you would put not enough information. You can write info. Not enough info. Because there wasn't one of these 4 relationships being used. All right, we move to the next one. Find the value of x. That makes m parallel to n. What relationship do these 2 angles have? They're corresponding. What do we know about corresponding angles? They're congruent. So what does 3x plus 5 equal? 65. Is 65 what x equals? No, it doesn't. 3x plus 5 equals 65, but x does not. Okay, we need to find what x equals. So we would solve this equation. What will we need to get x by itself, and it's attached to 3x, so we need to get that by itself. So we need to subtract 5. So 3x equals 60. Divide by 3, and x equals 20. You got it? Alright, so that would be all that we do here. We know that corresponding angles are congruent, so we set them equal, and then we solved. This next one, I want you to write a note off to the side, because we're going to be proving or determining whether lines are parallel. In order to do a problem like this, okay, I want you to state all, so you want to write this down, state all the relationships of the angles in the picture. All right, state all the relationships of the angles in the picture. So if you ever see a problem like this, just start listing what relationships you see. All right, so let's look. In the diagram, what does this statement say? R is parallel to S. If it didn't tell me that, what could I have looked at my picture and seen? The little arrows, okay, right here, showing that they are parallel. And 1 is congruent to 3, so I'm going to mark that they're congruent. 1 is congruent to 3. Prove that P is parallel to Q. So on this one, all that I ask of you is that you write the relationships that you see. We already know 1 and 3 are congruent, though they don't have a formal relationship. Let's find the relationship. Let's just start with 1 and 2. What relationship does angle 1 and angle 2 have? They're corresponding. So 1 and 2 are corresponding, which makes their measures what? congruent.
Any 11th grade student who is absent on picture day or needs a retake, please go to H18 at this time. Any 11th grade student who is absent on picture day or who needs to do a retake, please go to H18 at this time. Thank you.
So if angles 1 and 2 are congruent, okay, that's what that symbol means, congruent. All right, what other relationship? We already know 1 and 3, 1 and 2. What other relationship can we talk about? 3 and 2. Okay, so this relationship. So here's what I tell people because some of them get confused. How do I know what relationship they have? Only look at those two angles. So ignore the other part of the transversal. What relationship, if you just had what's in this box, what relationship would you think that they have? Alternate interior, I agree. So then you would say angle 2 and angle 3 are alternate interior. And what do we know about those? Which they're also congruent. So because of all of these things, the angles that are supposed to be congruent are congruent because we have corresponding angles, alternate interior angles. That makes the lines parallel. Okay, so this is what your final answer would be, just stating all the relationships that you see in the picture. Okay, we're almost finished. Transitive property for parallel lines. If P is parallel to Q and Q is parallel to R, what do we know about P and R? They're also parallel. Okay, so you could see, just like with, if you remember line segments, that's not going to be congruent, but when line segments were congruent, they had a dash. When angles are congruent, they would have like that curve mark. When lines are parallel, they have these arrows. So the number of lines, like up here, this has 1, this has 2. So would these two lines be considered parallel? No, because they have different number of lines. It's the same thing here. So if you see in this section of the picture, the first two are considered parallel because of those blue 1 arrows. And then the second two are considered parallel because of the red arrows, the 2 of them. But because the first 2 are parallel and the second 2 are parallel, that makes literally all of them parallel. Okay, so that's all it's saying, is that can transfer over. Okay? All right, so we do our last 2 examples on your paper. Find the value of x that makes S parallel to T. Then explain your reasoning. What relationship on number 1, what relationship do they have? Alternate exterior, which are congruent. Okay, that's my reasoning right now. Okay, alternate exterior are congruent. We're going to solve x because they are congruent. What do we do when 2 angles are congruent? Yeah, we set them equal. So 2 times x plus, what is it, 10 equals 3 times, bless you, x minus 8. All right, so what do we do first to solve? Distribute. So we got 2 times x, 2 times 10, which is 20, 3 times x, 3 times negative 8. Bless you again. What is my smallest x? 2x, so I need to move that to the other side. So 20 equals x minus 24. What is my last step to solve this problem? Add 24. So my final answer, bless you again, 44 equals x. So I had 2 answers here. The fact that they're alternate exterior, which makes them congruent, that's why I knew to set them equal and solve for x to equal 44. All right, the second, what relationship do they have? They're consecutive interior. What do you know about consecutive interior? They're supplementary. So does supplementary mean one angle equals 180 degrees? No, that would be a straight angle. What it does mean is that they add up and equal 180. So 4x minus 12 plus 120 equals 180. There was one other way to solve this. if you remember. If these two are supplementary, if this one's 120, yeah, you subtract from 180. So what would this angle have to equal? 60, yeah. So these were your two ways. You could do it like this, but if you're not comfortable, that's fine. I usually do it like this with my class anyways, in the green. So I would do minus 12 plus 120, which is 108. Going to subtract 108. 4x equals 72. Divide by 4. And x equals 18. Alright, so I had two parts to my answer. Consecutive interior angles are supplementary, and then x equals 18. Any questions? Okay. So here is the homework.